Welcome to TelcoBridges ProSBC TechTrain Module 255, covering TBanalytics, the tools included in ProSBC used to diagnose network issues.
So TBanalytics is just a grouping of all kinds of function like call trace, test call, signaling traces, media traces. So these are the things you can get out of the system to help you analyze what's going on and debug the system and maybe do some specific functions. So you have the status portal. We saw that earlier on. So you have how you can see what's going on in all the system. We saw who is master and slave in the databases. You can see this here. It's not really important who is master and slave, but you need to know that if one of them is unknown status is not good, right? You have to make sure everything is up in the system. The host, we went through this yesterday as well. So you have the features allowed on this system, the status and stuff you can do here. So upgrade the CentOS packages. You can do this from this status option. Shut down and reboot the system. And then reset roles. So either you reset the host role, so is it a primary or a secondary device, or the network interfaces. If you want to reconfigure the network interface, you have to go and reset network roles. So the features you have here is the SIP calls is what is important here. SIP registration is always set to the same value. The rest is only when does it expire. And like we were saying, there's an option to get a permanent license, and then the expire date is 100 years from now. Okay. It explains a little bit the different functions, but when you have ProSBC, you get all of those. And with when you have free SBC, if some of you are interested, we can go on the ProSBC site, and you can see what's the difference, what you don't have in the free SBC. So we talked about this yesterday. We showed this on your system. So it's important here to look at this sometimes, especially if you're having a lot of calls on the system, or if you are stressing out the system. You need to look at this. So applications here is all the applications running on the system, and this is only the TB router engine. All right? So the TB router engine will be the number of sessions that will pass through it, and if it needs to do SRTP encoding, that's what will affect the percentage here. The applications will be more, it doesn't show here, but it will be more the call rate that you have in the system. So if you look here at packet processing, that's really the TB router performance. You see here, it's very low, 3%, but if you have your system, I think it was 20% or something like that, TB router? Yeah. 15%, okay, 15%. Okay, so. But the important thing is to be able to verify where you are and where it would be blocking if you have something like this. Right, then these three applications, TB SIP, Gateway, and Engine, are the most important one. And what we've seen usually, and that we confirmed on their system as well, Gateway is about close to 2 times what TwoPack Engine will use for the same amount of calls, so in general. So it's really this one that will tell you if you're getting to the limit of this system. So either you need to add more cores if all the applications are running on the same cores, or you need to increase the speed of the CPU to allow for more calls through the gateway application. So this is a good metric to see. In the hardware units, you see the transcoding devices that you have in the system. In the transcoding device, you will see not control 0, control 1, but ETH 0, ETH 1, and not trans 0, trans 1, but VoIP 0, VoIP 1. Okay, but otherwise it's the same networks. And you can see also there is a license on those devices, but normally they are always permanent, those transcoding devices. Okay, so in the status of the SIP, you have the status of the SIP polling, right? So you will see here if the polling is enabled and if it is available. So it could be yes, polling is enabled, and no, it's not available. That means there's no response to the SIP options. You have information also if the SBC has registered to another system. So you have it here, registered to proxy. It would be yes here, and is it registered? Okay, if it was accepted. But that's only the SBC registering outside. You can see the number of active calls here. Yeah, instantaneous incoming call count. You have incoming, outgoing, you have total, you have ASR values viewed from the SBC.
Est-ce qu'on peut voir le nombre de copies simultanées maximum qu'il y a eu sur le NAP?
I need to look at NAP. Let me check.
On peut le voir sur l'ensemble des NAP, mais sur juste un NAP.
Oh no, you don't see it? What, just one NAP? Okay, wait a second. Let me check. List. So you say, okay. Highest. Okay, call rate highest. But that's only call rate. Instead incoming call count in progress answer. That's like total. Call rate highest. Yeah, maybe you're right. Okay, I can search for that. So it seems you have a call rate highest, but not necessarily number of calls highest. So we can check that if it's somewhere else. The call trace tool, we saw that this morning. So there's like a ladder diagram that tells you the incoming, outgoing calls. The default is 10,000, but you can easily increase it to 50,000. So you can have 50,000 sessions in the system that you can filter out quickly. The rest is stored on the disk, and you can search by date time. Well, everything that is here, you can search that. The data that is stored on the disk, do I talk about it? Maybe I talk about it. Let me continue here. You see the list of calls, how many calls in total are in the system. And then the display, because you can have a window, time range window here to display more or less calls in the system. You can see if the call is incoming, outgoing, the numbers dialed, and the route chosen. So that's the route name in the routing table.
So now, like, you can't click on a call and get the call details, right?
Yes, you can.
Okay.
You know what would be kind of cool? In the search of call trace, one of the options that you can search by is NAP.
Yep.
But because there's so many NAPs and there's so odd names and so on, sometimes if you have several for one company, it would be nice to be able to search to do a drop down or something there. So if you're looking at the call trace up in the top right hand corner of
Yeah.
your search,
Here.
yeah, you have to manually type it in. But if it were drop down, oh,
Surprise.
They can do that for me.
No, but it's, you need to type the first letter. Yeah.
Oh, so then it starts, okay.
Yeah, but it's true that it would be nice if it just take it, but no, I need
No,
to.
that's.
So if you put S, then maybe you don't. Oh, I have one.
Oh, cool, okay.
I wanted to check one which I had some call trace. Yes, I have it here. So these ones here, you click on it, right, and then you can see the trace. So, did that answer your question, or?
It's really handy.
Well, it doesn't really give you much detail.
Well, now, no, because it was a refused call, right? And this actually, it's even worse.
If you go like service, okay, let's see, okay, they're all outgoing.
Yeah, these are test calls generated by the system. There's like
Okay.
that's why we see only outgoing here. And I failed to find a system which has some calls on it. I can go on a customer system if you want to see some. Now, if you click on it, you see, and if you click on, let's say, I know these three here is the same call, right? There was an incoming and there was two outgoing calls for this particular case. If you click on this one, or this one, or this one, you see the same trace. See the same information, okay? So it's going to be this incoming and two outgoing calls of the system. You see the SIP call ID as well here, so that's useful when you want to search in Wireshark after. Okay, what else here? Yeah, okay, so this is the example of a call trace. We saw one earlier today. See, we see here it's SIP UDP. It could be SIP TCP or SIP TLS. You will see it here. It's the only way you can differentiate from the call trace here.
Does the call trace show you enough information for the RTP?
It shows you some of it, okay? So it shows you the codecs that were offered, the codecs that were accepted, and at the end, well, in the middle of the call, if there's no RTP traffic, it's going to show you no RTP received every 15 seconds or so. And at the end, it's going to give you a result of the RTP. So data on number of packets received, how many you dropped, sequence errors, buffer overflow.
We don't see the contact URI or the...
Contact, maybe not, no. No, we don't see it. And unfortunately, there's no configuration for the call trace. So the only way to fix that is you tell us what you need, and then we need to ask someone in the development team to add it into the call trace. So there's no configuration for that. So in the applications, here, things that you can do in the application is, for example, change the trace level. So you click on application, you choose the application you want, and then you can change the trace level. Normal trace level is 4, but you can decrease it if you want to debug some of the things. The other thing you can do, for example, a call trace, which actually the application name is tbsigtrace, you can change the maximum calls. So the default is 10,000. You can increase that. I think it's 100,000, the maximum. And then you can increase also the backlog of those call trace, so you can keep them for a longer time. There's just one special feature here, is that if you access one of the call trace, it's going to remember it at least for 12 hours here. Okay? It's going to stay in the memory. So you can re-access it later. It's going to stay in memory for another 12 hours. So this will, we suspect that the ones you looked at are more important than others. Right? And the call trace files are on the disk, and it's this path here. So you see tbsigtrace again. That's the path where all the log files are, and this one is for the call trace specifically. Okay?
Flat files?
No, No, that's what I was saying yesterday. You cannot read those files. The only way to see them is to put them in the same system. So take that file and upload it in the system or on another system. But you need a web portal to decode the information.
When you upload it into the same system, does it stop the call trace when it's currently
Yeah.
running?
Well, no, it doesn't stop it. It stops the memory. So you don't see any new calls in memory. Okay. It's still being put to disk. Okay. The new calls are being put to disk. You're looking at the one that you uploaded. Once you finish, then you just say resume regular processing, and then it's going to fill up the memory again. But it's going to clear up the memory that you have now of call trace. They're all stored on disk all the time. Okay? It's clear up, and then it's going to display this new one. Okay? So I didn't show here the process, but we have it on the wiki. So you need to log in with our tool, our special tool, and then say load this file, and then resume live capture. If someone interested, I can show you that later. The recording from the web interface, you need a transcoding unit to do that, but if you have it, you can enable call recording. Here we say for troubleshooting, most likely it's just to hear what is coming in on the line. Right? Sometimes they say quality is not good, stuff like that, so we can record what is coming in on the lines, and you can put some filters like this. So incoming NAP can be one specific NAP or any, and then you can filter on call and calling number. System will automatically, if it finds those values, will record this call. When you record a call, it will add a button in the call trace. So you see that this call was recorded, so you can download those files. Or you will also find them on the unit in this specific location. Yes?
You see that in the path, you have the 1, 2, 3, 5.
Yes.
Does that change automatically if you change the port from?
No.
No, so it's always, not that I want to change the port, I was just curious because I noticed it there.
This is more historical that we have that. However, in development, they use this, they call it a system ID, and it distinguishes different systems on the same network. Some of you guys had problems with that, but that's one way to distinguish them. But for customers, it's always 1, 2, 3, 5. There's other ways to separate the networks, but it's always going to be 1, 2, 3, 5, 8. So this is recording calls with the web interface. You can also do it in a routing script. So I talked about bridge parameters in the routing script. So if you say bridge parameters, record this call, it's going to record the call. You need to have the transcoding device. Okay. Test call, okay? Just this morning in the call routing stuff, we did test routing scripts. All right? So you could generate a fake call in the system and see how it's going. Then you have the test call feature here, which is a real call that is generated. All right? So either it is a real outgoing call, so you choose in the test call where you want to send the new call with what information you want to set in there, and it will make the call and someone can answer at the other end. Okay. If you have the transcoding device, you can also send data. It will send RTP. That's what we confirmed yesterday. It will send RTP for that call, but it's going to be silence if you don't have any transcoding device.
So will it be like echo?
Echo?
Like is it, you know how on a plot you get feedback, you get battery? You gonna get any sort of feedback? No? Okay.
No.
Not without an audio.
No.
Okay.
Or you can simulate an incoming call. So that's to simulate if you're receiving something. So if you cannot generate a real call, then you can generate a real configured call. Right? So with this, when using incoming call, you can verify your routes to make sure they are working correctly. You can verify your routing scripts that you have done. So you can simulate, like we're talking about a, what is it called? It's a is transfer private header. So if we do the script to extract this field, well, we can test it with test call before doing a real test call. Your route retry, you can try that again. You can verify the call parameters, right? The ones that you receive, are they processed correctly? And you get a live call trace status. So at the bottom of the test call page, you will see a call trace from what you're trying to do. So you will see which NAP you called. So you choose here the NAP, which call number that you're using. If you have transcoding, you can put a file here or a tone string. You can put just tones that you play. Here you can also record, so you will record what is coming back from the call. Here you can put additional parameters. So if it is an outgoing call, on the outgoing call it's going to add this SIP header and maybe calling in away, which is more for SS7. If it's an incoming, so if you change this to simulate incoming call, then here we will simulate that you're receiving an X origin IP, and then maybe in your routing script you decode that SIP header. Okay?
To play a file, you need a transcoder? Or?
To play a file, you need the transcoder.
So for test call, we don't need transcoders.
The signaling trace, we talked about that. Okay, so well, we talked about it, but we didn't do it a lot. Okay, so wait, give me a second. You can capture your SIP traffic, only your SIP traffic with this tool. And you can use SFTP to get the file. So you can start the application and then SFTP to get the file. However, there is a way to do a direct signaling trace to Wireshark. Right, so I will show you this. Right. So the standard procedure, you connect SSH to the unit. You start tbsigtrace. So you can start just tbsigtrace like this, or if you want to make sure you filter out just the SIP messages, it's -SIP, but tbsigtrace would be enough. Once you're done, you can do Q to stop the application. Then you can go in this folder. See, it's always the same path for all the applications. tbsigtrace, and then you can get the new file that is created. This file is open you can open it up in Wireshark. If you go in Wireshark, there's a few elements here you can use. So for example, SIP2 user, SIP call ID, you can put that. Here also is, that's when you get only the RTP trace though. So you can see both RTP traces if you know the UDP ports that were chosen. Right? So that's useful. Then what you can do is a live capture. So the procedure is like this. You download the P-Link program. There's maybe others existing to do that, but that's the one I know how to make it work. You execute the command. Okay, so for example, SIP capture, you use P-Link. You put in P-Link -SSH how to connect to the system, user and IP, password. Starting from here, it's the real command. So tbsigtrace -stdout. Here -IP, well, in this case, it's going to be the same as SIP, but you can just omit that. Then you have a pipe And then this is the Wireshark path on your local disk. Dash K, dash I, and dash. Right? This is the same as this, right? Dash K, dash I, dash. And it's piped to your Wireshark. Right? So, let me show you something. So I can go to a system like this, tbsigtrace, and it's gonna start capturing the SIP. Okay, as soon as I get at least one packet, it's gonna create the file. Quit. If you do tb setup, you get straight to the log file directory. Well, and there you have the new capture file that you have done. All right, so that's one way to do it, and you can extract this file. The other way to do it is to use the p-link. So it starts pcap, and then we'll receive some packets, hopefully, for my demonstration. I need some packets. Anyway, so it starts Wireshark automatically. You see it open another window here and pass the p-link commands, and it will display at some point some zip calls. I can try maybe.
Is there a way in the tbsigtrace to specify a filter?
Of what? You mean IPs and stuff like that?
Yeah.
No. No, you need to capture everything and then.
So it's an all or nothing thing.
There it is. Okay. It's all or nothing. Yes. Yes. It's, well, actually you can do it, but it's more complicated, right?
If you type it in Wireshark and you're doing live capture, you can filter it, right?
Yeah, here we can filter. So we can filter, I don't know, whatever we want here.
Well, I'm thinking more as on a very busy system.
Yeah.
You're trying to capture like the signaling for one call. It's going to be, okay, now I got to go through a wire. Now I got to go through a PCAP that's 100 megs.
Yes, yes. There's, wow. No. It's difficult to do. You have to capture everything, and then filter it out with Wireshark.
Is it the same thing with the RTP capture?
Same thing with an RTP capture, yes. Yes. Well, the only filter I can do with the RTP capture is if there's a specific LAN 1 interface. So you can get only from one LAN 1 interface. But if you don't know which one, then you have to capture everything.
So really the only record you have, or records you have of previous calls, because you're not capturing at the time, is your SIP trace, your SIP call, your
Call trace.
call trace,
Yes.
and your CDR.
Yep, exactly. Call trace and CDRs, and here, normally, most of the time I guess you get enough information, but if you want to dig deep down, you have no choice to get a real trace. And
Right, and get it to happen again.
Yes.
Whatever it was. That's always the challenge.
Is that something on the roadmap perhaps?
For?
To do filters within the traces?
Not short term, that's for sure. Not short term. You're worried that it's going to be very big?
I mean, I do captures, if I do a capture now, I could have 100 concurrent calls going on, and then to try to find one out of that 100 is not the easiest thing to do.
Yep.
And that's on a small system.
Yeah. It's meant to be used for short periods of time, as much as possible. Yeah. So if we find, well, let me check. Maybe there's something we can do. But let's say basic is capture everything.
Would Homer do that in your case, Dave?
Homer grabs the signal, doesn't grab the RTP. But it's usually enough to
Yeah.
It's when I have to capture, that's when I'm looking for the RTP, and then, again, you have, say
Yes.
2,000 calls, and you're looking at trying to find the RTP out of 2,000 calls, and it's difficult.
Yeah, sure, absolutely. Capturing the RTP for other calls is not something easy. So I think the best way is to try to figure out from which networks there is a problem, and then try to, target this one more as much as possible. But
You drill down in Wireshark.
it's difficult. You can drill down in Wireshark, but what he's saying is the files are very big, right? So
This one works. If you try to capture an RTP stream, depending on what you're doing, could last 2 or 3 minutes.
yeah,
2
exactly.
or 3 minutes over 1,000 concurrent calls.
That's right.
That's a significant amount of traffic.
Yeah, absolutely.
Many hundreds of megabytes.
Yep.
If Wireshark doesn't crash.
Yes, exactly.
Yeah.
Exactly, so too. So I mean, if you could filter it at the hardware level and say, okay, I just want stuff that's going to and from this IP.
Yes. Well, okay, so the let's say tbsigtrace right now, there's no enhancement plan for doing filtering of anything. TB router is a different story, because then it's the number of packets is 100 times more, right, for the same amount of time. So, and this there are already been requests done probably a year ago, but again, so many things to do that this part is like, and we thought at the beginning would be a big problem, but finally we always find a way to make it work, right? Be able to understand where's the problem and fix the RTP issues. There's much more SIP issues than RTP issues, normally.
I mean, one thing that I can think of is with the call recordings, there's the ability to turn that on and off based, is that a global parameter, or is that?
The one that you saw in the web interface is a global parameter, but you can filter it from NAP, from calling numbers, stuff like that. But that's the only thing you can do. If you go in the routing scripts, then you can do whatever you want. Right? You can put any types of reason or condition to record. Right?
Okay, and once you have that recording, are you able to then use that can you look at the RTP stream in that recording? Or
No, you get the data that is in the RTP, decoded data that was in the RTP. So it's really to listen to the quality of the signal.
So you're getting a WAV file from that.
Yep, a WAV file. Yep.
You can't actually look at the RTP payload from that.
No, it has been transcoded, if it had to be. It has been un-RTP'd and put in a file. Yeah. So that was yes, the signaling trace. TB report is when you have a problem in the system and you want to get logs for a certain period of time. So usually when you see a problem, you get the logs for the last 4 hours or the last day. And then you do just create TB report here. It's going to create a file which sometimes gets pretty big depending on the call trace level you have put. Right? If you put call trace level 1, it's going to get bigger. Or if you put a bigger range of dates here. However, in there I get a lot of things from the system. Right? A lot of information from the system. All the logs we saw, all the application logs we saw before. We're getting also information about if there's the transcoding units. We're getting information about TB router special logs, so a lot of things. It gives us a very good idea of what's going on in the system. It also takes a configuration backup. So at the same time as you do this, it's going to take a snapshot of the database, right? So when we receive this TB report, I can take this database, put it on one of my systems, and I see your configuration, right, with a web portal. The audit logs we saw, right? We talked about that yesterday, so I'm going to skip that. Other troubleshooting you can do. Well, we saw you can access SSH to the device. We saw yesterday the little application, which is really useful. Other CentOS commands, well, all the CentOS commands are there, the ones that we have installed on the system. So, for example, IPA, the YUM update, we talked about that yesterday. Messages about the host. So this could be interesting if it's something related. Let's say you have your hardware running. So you get information about when it was powered up, maybe the Ethernet driver status and other stuff that is logged from the system. You can use top to see CPU and memory usage. Sometimes it's okay to use this, but it's much better from the web portal because it gives you all the applications separated by application, TB router, everything. Here, TB router, we saw yesterday, it shows 100%. And we know it's always running at 100%, but really only running at 3%, right? Or 6% or 15%. The TB Toolpack service, here you can start, stop, or see the status. This will stop all the applications on that server. Right? So if you do that, you just like if you're shutting down the server. Right? So we use this sometimes for doing tests. Or one of the things I showed you yesterday is if you want to reboot on an older version and for some reason you don't have access to the web portal or it's not working, you can force it, changing the files and do stop, start. It's going to restart on the older version. Other useful commands, you saw me type this a few minutes ago, TB setup, so you get to all the log directories. TB bin, you get to the application directory, not that you have to do that, or it's not really useful, but it's a shortcut. Journal control, XC, other information on the system, which is interesting. Some of the things I know TB router logs in this particular log, so you get this information. LSPCI-NVV, there was another one also, another command here similar to this one. TB router logs are in a specific directory on the disk. I'm missing one of the commands, I'll show you later. Configuration database backup, we saw that yesterday. You can do it in the web interface. It's also available if you do a TB report, but you can also do it manually like this, MySQL dump, to do your dump. However, here it says 2pack30, it's 3.1 if you're on version 3.1. You can access the database. That's probably what Christian is doing now on your system. And one of the things I do is sometimes when I receive a database from a customer, they don't tell me the password, right? So I just reset it this way. So it's just a MySQL command to reset. So it now becomes root. This tool we saw yesterday, it's a runtime log viewer. So you need to select which application. So use the arrows up, down to select, or you press the letter of the application. Now you gain full control of the application. So you have to be just a bit careful when you have access to that. If you do quit, it quits the application. It will restart like 1 second later, but still you quit the application, right? So you have to be careful. So, and the trick is to press escape twice to exit application control. All right, so that's just a little, you have to get familiar with it a little bit. All right, so this is what we saw yesterday. Tab to change menus up here. And then and then you see status. Here is the log. That is what is written in the log file. And the rest here is live status of what's going on. The packet capture, or to get the media of the system, then the only way to do that is with tbrouter. So to access tbrouter, you need to use this program again. You select tbrouter, P to start capture, P to stop capture, and the files will be the media file, the PCAP file will be located here. You see there's a little bit of filtering you can do, but not a lot. Capture mode, so you can select only in, out, but normally it would be both ways, right? You can use just one VLAN, so there's a little bit of filtering, but not as much as it would be very useful. Ah, there's my command. There's my command. Alright, dpdk tbtool.py-s shows dpdk and kernel drivers. So it is interesting, especially when you install the system the first time. I need to give the full path of this application. I think it's this one. Yeah. So you can see here on this particular system, I have seven VMX Net 3. So this is a VMware system. And I have 3 kernel drivers. So management 0 here and control 0, control 1. So these 3 are going directly in the kernel. These other ones are all managed by tbrouter, right? Anything that you see dpdk, that's tbrouter, okay? And then you have the nic.json file. It's an important file that assigns the network interfaces to the cores for the LAN 1 interfaces. Okay. So in this file, it's not a very long file, but it has names, for example, management 0, control 0, LAN 0, stuff like that. And it tells you the role. And the only one that are interesting is the one that says dpdk in this file. And then core, it tells you on which core you will run this network interface. So that's where you can match how many cores on the network interface. When you install the system the first time, it will look at your hardware and try to fit correctly for the system. I would say 95% of the time it works fine the way it's pre-configured, but sometimes we have to adjust it, change a little bit how this the cores are assigned compared to the network interfaces. Okay. So the way you will notice here is maybe you have performance problems on the system, it's not going as high as you want, or you get SBC scheduling problems, stuff like that. So then the best is to talk with us and we verify the hardware, this file, and other stuff, and make sure that it's doing as much as it can. The transcoding unit, well, you can access it, but this one you access it with telnet. And the IP address of the control ports or ETH0 ports of the device. All right, so you can see this IP address from the system you have added it, or there's a way also with the serial console to look at the IPs there. Some commands you can do on there, very low level commands, tells you information about the unit itself, which version it's starting, the ports, the Ethernet ports on there. Most likely you will never need to to play with that. These are low-level commands, all right? So this is an overview of all the tools that we have. You need, of course, I guess, to, you know, try to use them. Try to do the commands and see if it does what you want.
Congratulations, you are now a TBanalytics master. Time to move on to the next module by clicking in the box over here.